Let us now proceed and check out what is the arithmetic operator in Java. Now the arithmetic operator helps us to perform the mathematical operation between two variables or numbers. So we have the add operator, subtract, multiply, divide, and also the modulus operator. The modulus operator simply divides two number and gives us the remainder in the output. So here we have 3 modulus 2. So when we divide 3 by 2, we get the remainder of 1 as a result. And rest of the operator such as add, subtract, multiply and divide are self-explanatory. So let us check out the arithmetic operator inside our IntelliJ IDE. Let us remove all these code and let us change the comment to arithmetic operator. So first of all, let us explore the modulus operator. So if I use 9 modulus 2 and end the statement with the help of a semicolon, then the IntelliJ IDE shows that it is not a statement. So when we divide 9 by 2, it gives us some remainder, and that remainder is a result that needs to be stored inside some variable. So on the left hand side, let us use int result equal to 9 modulus 2. So when we are going to print out the result by using the print statement system.out.println. Now every time we don't need to type the whole statement. Now instead of this, we have a shortcut inside the IntelliJ IDE. That shortcut is simply type SOUT. Hit enter and it will automatically generate the print statement for you. Let us print out the result. So here we get 1 in the output. That is, when we divide 9 by 2, we get the remainder of 1. Now let us try something different. 8 modulus 2. Let us run our code. So here we get 0 as a remainder. So when we divide 8 by 2, we get the remainder of 0. And now let us use 9, let's say, divide by 2. Let's see what happens. Now in the output we get only 4. We all know that when we divide 9 by 2, we should get the output of, let's say, 4.5. Now what happens is that on the right hand side I have 9 as an integer and 2 as an integer. So what happens is that when we divide 9 by 2, the result is being stored inside the int result. Now integer data type does not support the decimal point values. So when we have this operation in the runtime, this 0.5 is striked out. So we get only 4 in the output. So in order to get 4.5, let us use float that supports the decimal point value. Let us now run the code. Now still here we get 4.0 in the output. But as per our expectation, we should get 4.5 in the output, which does not happen. So what happens is that this 9 is basically a int value and this 2 is again a int value. So when two integer values are divided, it gives out the integer result. So here in place of 9 by 2, we get 4. Now due to the type conversion that we checked out in the previous topic, this 4 will now become 4.0, which is present here. So what is the solution for that? The solution is to either make this 9 as 9.0f. Right, because 9.0 is a floating point value, that is why we need to append f at the end. Let us now run the code and let's see what happens. And there we go, finally we get 4.5 in the output. Now another alternative to this is to make the denominator 2.0 as a floating point value. Let's see what happens. And there again we get 4.5. So either you make 9 as floating point value or 2 as floating point value in order to get the desired result. Now another alternative solution to this is simply cast it to the float. So when 9 is divided by 2, it simply gets converted into the float value. So let us now run the code. So here again we get 4.5. So always remember, whatever value that you have on the right hand side will be assigned to the left hand side. And now if I make it, let's say, double and then remove it, let's run the code. Again we get 4.0 just because on the right hand side I have two integer value getting operated. Let us now change it to 9.0, which is again the double. Let us now run the code. And then we get 4.5 as the desired result. And now, apart from modulus and division, you can also perform various other operations such as 9 minus 2, 9 plus 2, and also 9 multiplied by 2 that should give us result of, let's say, 18. Let us now run the code. And there we go, we get 18 as the output.